This row we're looking at in geometry. This is part A, lesson 17. And we're going to try to talk about when a quadrilateral is a parallelogram. So we had some rules or theorems in the lesson. These are the converse of those theorems that talk about how you can determine if a quadrilateral is a parallelogram. So let's take a look at some of these rules. Here is a quadrilateral. We're going to assume that we can prove that it's a parallelogram by showing the following things. So when is a quadrilateral a parallelogram? Well, one of the rules was the opposite sides had to be congruent. So that was theorem 17.5. In this particular problem, if AD right here is congruent to BC and AB right here is congruent to BC, then this is a parallelogram. Let's take a look at the next one. So if an angle is supplementary to both of its consecutive interior angles, consecutive angles. So for example here, this is theorem 17.6. If A is supplementary to B, so if A plus B, measure of angle A plus the measure of angle B is 180, and the measure of angle A plus the measure of angle B is supplementary, then we can say that this quadrilateral is a parallelogram. Let's take a look at the next one. If both pair of opposite angles are congruent. So this is theorem 17-7. So here we're looking at the angles across from each other. So angle A right here would have to be congruent to angle C, and angle B would have to be congruent to angle B. If we can show that, then this parallelogram or this quadrilateral is a parallelogram. Okay, and then finally, if the diagonals bisect each other, this is theorem 17-8. So we've got our diagonals. We've got a point right there in the middle where they intersect. If we can show that AE is the same as CE and BE is over here, BE is the same as DE, then this is a parallelogram. So those are the converse of the theorems that we had that showed you the characteristics of a parallelogram. So if we can show that these are true, then we can state that any quadrilateral could be a parallelogram. So let's take a look at how we're going to apply some of these. So we're going to find the value of x and y here that would make this quadrilateral a parallelogram. So what do we know here? We're given stuff about sides. So we're going to use the first theorem that we talked about here, which is that the opposite sides have to be congruent. So 4x minus 2 would have to be the same as 3x plus 3. And then 3y would have to be the same as 4y minus 4. So we set up these equations. 4x minus 2 equals 3x plus 3. And now we're going to solve that equation. Get the variables on the same side first by subtracting 3x. And we're going to add 2 to each side. And so x would have to be 5. But we also have to show that y, these two sides also have to be equal. We have to show both are equal in order for this to be a parallelogram. So we have to set up this equation. 3y equals 4y minus 4. Same properties. We're going to subtract 4y from each side to get y's on the same side. And now we have negative y equals negative 4. Remember, we want our variable to be positive, so we're going to change that sign on both sides to get y equals 4. So in order for this to be a parallelogram, x would have to be 5 and y would have to be 4. And this is exactly something you'll have to do in the lesson assignment. Let's take a look at this. So we're given something about angles here. So I would assume, since we don't have anything about this angle, that we have to show, and it's probably this one, is supplementary to both of these angles. So we're going to start with these two, because I've got two different variables here, so I can't do an equation with those. But I can do an equation with these since that would only have one variable. So in this particular case, we're going to have 5y plus 5 plus 75. So that's adding these two angles together, and that's going to have to equal 180. So we're going to combine like terms. We get 5y plus 80 equals 180. We're going to subtract 80 from each side. And that gives us 5y equals 100, and then finally divide by 5, and so y is 20. So in order for these two to be supplementary, y has to be 20. So how are we going to find x? Well, there's two ways we're going to do it, but we're going to stick to the property, and we're going to show that these two are supplementary. We're going to use this value of y in this expression to get the measure of that angle. So we're going to substitute. So we're going to have 3x plus 105. Now, where did 105 come from, Mr. Rowe? Well, 5 times 20 is 100, plus 5 is 105. So that's those two angles added together. Now we're going to solve the equation. We're going to subtract 105 from each side. So that gives us 3x equals 75, which if you look right here, this was the other way we could have done this. We could have set these two equal to each other. And then finally, if we divide by 3, x is 25. So that's using the property as it's kind of shown in the lesson. So there again is something you're going to have to do in the lesson assignment. And let's take a look at this one. Looks like we have information about all 4 angles, so we're going to probably use that the angles across from each other are congruent. So let's start with x. So 3x would have to equal 78. So what does x equal for this to be true? Divide both sides by 3, and so x would have to be 26. So the other equation, we've got 6y plus 6 equals 102. Again, it's a two-step equation. I'm going to subtract 6 from each side. That gives me 6y equals 96. And then we're going to divide by 6 on each side. And that's going to give us y equals 16. So for this to be a parallelogram, y has to be 16 and x has to be 26. And we got one more property, which is the diagonal property. So the diagonals have to bisect each other. So that means that these two have to be congruent and these two have to be congruent. So that's the equations I'm going to set up. I'm going to start with 4x plus 12 equals 6x. We're going to solve this, get the variables on one side first. So I'm going to subtract 4x from each side. That gives me 12 equals 2x. Divide by 2, and I'm going to get x equals 6. So x has to be 6 for these two to be equal. But we also have to show these two are equal as well. So we have to solve that equation. So 3y would have to equal y plus 18. We're going to subtract y from each side. That gives us 2y equals 18. And if we divide by 2, y is going to equal 9. So this is the converse of those first 4 properties that we talked about in the lesson. And this is how you're going to have to apply or do application problems in your assignment. I hope this helps you with that assignment. If you still struggle with this content, please let us know in a teacher message or make an appointment for a help session.